Good day, learners. You are welcome back to our mathematics class for today. In today's class, we are going to be looking at the continuation of our previous topic, which is probability. In our previous topic, we discussed on the general formula of probability. Then today, we are going to start by looking at the theoretical probability. But before we venture into this properly, if you are a new member on this channel, kindly subscribe to my channel, then click the notification bell for my subsequent content. For our loved ones that have been on this channel for long, don't hesitate to like, share, and leave a comment as we move on. So, let's dive in. Theoretical probability is what we are going to be discussing today. The word theoretical means that a probability that is based on an assumption, that is, no experiment is being performed for it. It is based on an assumption. So how do we go about this? So let us now buttress this using various examples. Example 1, two numbers are chosen at random from 1, 3, 6. Find the probability that the sum of the two is not odd, meaning the sum of the two number picked is not odd. We have to understand this odd and also the meaning of not in probability. Now, looking at this, two numbers are chosen at random from 1, 3, 6. Find the probability that the sum, meaning that when we sum the numbers together, the probability are not odd. So we have, let's do it this way, we have 1, 3, and 6 as a number. Then we arrange it with 1, 3, 6 as well. Let's look at it this way. Let's add it together because here is sum. 1 plus 1, I have 2. 1 plus 3, I have 4. I have 7 here. 3 plus 1, 4. 3 plus 3, 6. 3 plus 6, 9. 6 plus 1, 7. 6 plus 3, 9. 6 plus 6, 12. Now, to work out the probability of not odd, we are going to look for the probability of odd. Then we now take it away from 1. What are we saying? Number of odd. Number of odd. How many odd numbers do we have here? We know very well that odd numbers are numbers that when divided by 2 leaves a remainder of 1. So here, you can see 7 as an odd number. So when we add 2 together, 7 is an odd number. Then followed by 9, odd number, another 9, then 7. So we have 1, 2, 3, 4. We have 4 numbers here that are odd. What is the total number of sample space here? 1, 2, 3, 4, 5, 6, 7, 8, 9. So number of sample space is equals to 9. Probability of odd numbers will now equals to number of odd over number of sample space. That is 4 divided by 9. But what we are asked to do is not odd. So probability of not odd will be equal to 1 minus 4 over 9. Let us say over 1 here. The SCM here is 9. 1 goes in 9, we have 9. 9 times 1, we have 9 minus 9 goes in 9, we have 1. 1 times 4, we have 4. So 9 minus 4, we are going to have 5 over 9. Example 2. The probability that a number selected at random from 41 to 56 is a multiple of 9. That you want to select some multiples of 9 between 41 and 56. Now, the first thing is to list those numbers. Let us list those numbers. We have 41, 42, These are the numbers that we have listed. We now to bring out the multiples of 9. So the first number is 9. 9 plus 9, we are going to have 18. So when you add 9 to 18, you have 27. When you now add 9 to 27, because there's no 27 here, so 27. So when you add 9 to that 27 again, here we are going to have, that is 6. I'm going to have 36. There's no 36 here again. Put another 9. When you add it up, we have 5. That is 45. So there's a 45 here. Now, another 9 again. Here we have 4. That is 54. So there's 54 here. Another 9 again. We have 3 here, 63. And the end number here is 56. So which means there's no 63 here. So the multiples of 9 that we have between 41 to 56, they are just 2. So we now have number of, let me use M for multiples of 9. So 1, 2. We have 2. Then number of sample space. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We have 16. Then probability of multiples of 9 will be number of multiples of 9 over number of sample space, which gives 2 divided by 16. 2 here, 1, 2 here, 8. Finally, we have 1 over 8. So this theoretical experiment gives 1 over 8. 3. A fair coin is tossed 3 times. Find the probability of getting 2 heads and 1 tail. That is a fair coin. And we know a coin has 2 faces, the head and the tail. These 2 faces now is now tossed 3 times, meaning that we are going to have it that the 2 faces are tossed 3 times, meaning we have head and tail, head and tail, head and tail. So how many sample space are we going to have? Since they have 2 faces, let me say 2, it was tossed 3 times. 2 raised power s, number of sample spaces. That is 2 raised power 3. So the total number of sample space that we must have should be equals to 8. 2 in 3 places. Now let's look at it this way. Now let's first of all add the 2 faces together, head, tail, and head, tail. We have head and tail, then plus head and tail. So we have head, head, with this one, head, tail, with this tail, head, with this tail, tail. So the sample space that we have here, they are in this box. Now, since they are tossed 3 times, this is 2 times, the first one and the second one. What of the next one? Now, the result of this one will now be used for the last one. That is head, 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 tail, tail, head, then tail, tail. So we use against head and tail. Now let's do this. This and this. We have head, head, head. With this one, head, head, tail. With this, head, tail, head. With this, head, tail, tail. This and this, tail, head, head. With this, tail, head, tail. With this, tail, tail, head. With this, tail, tail, tail. So these are now the total number of sample space. 1, 2, 3, 4, 5, 6, 7, 8. Total is 8. Now, the question now is find the probability of getting 2 heads. Probability of getting 2 heads and 1 tail. This is 2 head, 1 tail. This is 2 head, 1 tail. This is 2 head, 1 tail. So there's no more 2 head, 1 tail again. How many do we have here? 1, 2, 3. So which means that number of 2 heads and 1 tail will equals to 1, 2, 3, 3. Number of sample space is equals to 8. So probability of 2 heads and 1 tail will be number of 2 heads and 1 tail over number of sample space. That is 3 over 8. So this is how to go about this theoretical probability. So let's look at other examples to buttress this theoretical probability again. Example 4. Now before we now proceed in this example 4, if you are a new member on this channel and you find this class interesting, don't forget to subscribe to my channel and turn on your notification bell. So when you turn it on, click the personalize so that you can be seeing our subsequent content. Now, example 4. 2 fair dice are tossed together once. Question A. Draw the sample space for the possible outcomes. 2 fair dice. We know that a die has 6 faces. So we now have 2 fair dice now. That is, we have so these are the fair dice. We have 1, 2, 3, 4, 5, 6, and 6 here. Now, since there are 2 fair dice, we have to sum it together because we need to get the total of 7 or 8. That is, 1 plus 1, I have 2. 1 plus 2, I have 3. 1 plus 3, I have 4. 1 plus 4, I have 5. Plus 5, 6. Plus 6, 7. So we're going to populate the rest. Now, we feed the table. Now, how many number of sample space do we have? Like total number. When you count everything that is here, we equal to 36. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 6 times 6 is 36. Now, we are done with question A. Now, question B. For the question B, we are asked to find the probability of getting a total of 7 or 8. Look at that word, or, that is here. The meaning of or in probability means that addition, or in probability means addition. So we are still coming to treat the rule of addition. That's probability of addition. Now in this case, let us now look for when they sum it together, you get 7. So these are 7. Then these are 8. Now, how many 7 do we have there? Number of 7. 1, 2, 3, 4, 5, 6. We have 6. Then, that's the number of 7. Probability of 7 will equals to number of 7 over number of sample space. We know our sample space to be 36. That is the number of sample space is 36 when we count everything. Now, number of 7 is 6 divided by number of sample space 36. 6 here 1, 6 here 6. So we have 1 over 6. Fine. The next one is number of 8. How many 8 do we have? 1, 2, 3, 4, 5. We have 5. That is 5. So probability of 8 will now be number of 8 over number of sample space. Now, what's now the probability of 8? Probability of 8 will be number of 8 is 5 over 36. Now, the next step is to now look for the word or means addition. It means to add them together. So, number, probability of 7 or probability of 8 will be equals to probability of 7, we have 1 over 6. 1 over 6 plus probability of 8, we have 5 over 36. The LCM here is 36. 6 goes in 36, we have 6. 6 times 1, we have 6 plus 36 goes in 36, we have 1. 1 times 5, we have 5. 6 plus 5, we have 11 over 36. So this is the probability of 7 or 8. So the next one is probability of less than 4. Number less than 4 in this place. 2 is less than 4. 3, 4, 2, 3, 3. So which means this circle this way, they are the number less than 4. So how many do we have there? 1, 2, 3. Number less than 4. Let's use that symbol less than 4. We have 1, 2, 3. We have 3. Then probability of a number less than 4 will be number of less than 4 over number of sample space. Number of less than 4 is 3 over number of sample space is 36. 3 here, 1, 3 here, we have 12. So we have 1 over 12. So this is how to go about this. So probability questions are somehow simple when you follow the step by step. So don't miss a class in this probability. You will actually find probability very simple as we move on to the conclusion of the topic. Next example to be example 5. A number is chosen at random from the sets 1, 2 to 10. What is the probability that it is an odd prime number? It is not that they are asking for the probability of odd number or prime number. They are asking for the probability of odd prime, meaning that there are some numbers that are odd and as well, they are also prime numbers. So, but the first thing is we must understand our numbers first. Let's say we have a set, the sample space, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Our sample space here now, they are 1 to 10 has been given. So we now want to identify what's our odd number here, odd numbers. What are odd numbers? Number that when 2 divides leaves a remainder of 1. Now, that start from, we have 1, and it will be increasing by 2, we have 3, we have 5, we have 7, we have 9. These are the odd numbers. Then what are the prime numbers that we have here? That is number that only 1 and itself can divide. Starting from 2, we have 2. Then only 1 and itself, we have 3. Then we have 5. Then we have 7. 9 is not a prime number because 1 can divide 9, 3 can divide 9, 9 can divide 9, 3 things can divide 9. But in prime number, only 2 things must divide that number. Like 2, 1 can divide 2, 2 can divide itself. Now, where did they meet? Where do they have something in common? We have 3, we have 5, and we have 7. So meaning that odd prime numbers equals to 3, 5, and 7. So how many? 1, 2, 3. There are 3. Number of odd prime equals to 3. Number of sample space, meaning the total number given to us, when you count it is 10. Number of sample space is 10. So from here, probability of odd prime number will be equals to number of odd prime over number of sample space. That is 3 divided by 10. So this is the probability of odd prime numbers. Example 6. And this is going to be the last example for this class. A die and a coin were thrown once. What is the probability of getting a head and 6? We have a die. I know a die has how many faces? A die has about 6 faces. And a coin has just 2 faces. So we have for the die. Now, this is for the die and this is for the coin. So die, a coin and a die. So when you populate this, these are what we have. How many number do we have in our sample space? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12. Now, number of getting a head and a 6. Head and 6. Head and 6. This is head and 6. Do you have any head and 6 again? None. So that is 1. So probability of head and a 6 will now be equals to 1/12. So we've come to the end of the theoretical probability. Until we meet in the next class, don't forget to subscribe to my channel and click the notification bell for my subsequent content. Also, share, like, and leave a comment as you leave the channel. Thank you very much.